Okay, so welcome back. Now that we've talked about circles, the next thing we're going to do is we're going to take a bit from section 2.2 and discuss something called a piecewise function. And what we need to be able to do is evaluate piecewise functions at specific variable values. We need to be able to find the domain of a piecewise function, and we need to be able to determine if a function is increasing, decreasing, or constant over certain intervals. Well, our main goal right here is determining if a piecewise function, what it means to evaluate something like, well, this monster. It looks terrible, but in fact, it's actually a very simple thing. And let me describe how it's looked at. This is a function in which the y value is determined in different ways for any value of x that you put in. So the way you might read this function actually seems a little bit backwards, but if you follow it, it says, all right, f of x is equal to one of three choices. Either f of x is equal to the absolute value of x plus 2 when we substitute in values of x that are less than or equal to negative 2. F of x is equal to x squared plus 4 when x, the number that we substitute in for x, is greater than negative 2 but less than or equal to 5. And then f of x is equal to 2x minus 1 whenever we substitute in values of x that are greater than 5. Well, what does that mean to us? Well, let's take a look at this. It says evaluate the function f of x at x equals 0, x equals 5, x equals negative 2, and x equals negative 6. Well, all right. Actually, that should be positive 6. I don't know what happened there. Let's try correcting that. There we go. Okay, we're going to evaluate the function at each of these points. Well, what does that mean? Let's say we're told to evaluate f of 0. Well, f of 0 is going to be evaluated in only one way, right? If it's a function, we can only evaluate the function for one value of x and only one way to get a value of y. So we look at what condition meets it. Well, when x is between negative 2 and positive 5, we use the piece of the function that says x squared plus 4. And that's it. We don't use the other pieces because 0 is not a number that's less than or equal to 2 and not greater than 5. Right? So if we evaluate that, then we find that f of 0 very simply is equal to positive 4 because we use this second piece right here. Right? The way we think about this is at x equals 0, f of x is specifically the function x squared plus 4. That's all it looks like as far as x is concerned. So f of 0 would be equal to 4. How about f of 5? Well, at x equals 5, we ask what does f of x look like as far as x is concerned? Well, it says when x is less than or equal to 5, so that includes 5, it still looks like x squared plus 4. So as far as x equals 5 is concerned, f of x looks like x squared plus 4 and nothing else. So f of 5 would be evaluated as 5 squared plus 4, which is to say 33. So f of 5. How about f of negative 2? What does it look like? Well, as far as this function is concerned, at x equals negative 2, f of x looks like the function absolute value of x plus 2. So we would be substituting in negative 2 in just this top piece. So at x equals negative 2, we're going to find that f of negative 2 is equal to the absolute value of negative 2 plus 2, which is to say 0. Right? So f of negative 2 is equal to 0. Again, notice that the only thing that's happening right here is that we're just choosing where the value of x fits in to the domain, right, this split domain, and figuring out what the y value is that goes with it. What about x equals 6? What happens there? Well, if you're looking, 6 is a number that's greater than 5, so the function at x equals 6 looks like 2x minus 1 as far as x is concerned. Because it says y is equal to 2x minus 1 when x is greater than 5. So we use this piece of the function to evaluate, and we find that f of 6 would be equal to 2 times 6 minus 1, which is to say 12 minus 1. So f of 6 is equal to 11. So the last question here on this page asks, well, what is the domain of this function then? I mean, it's split up, right? Well, the domain itself consists of these three pieces. We have the set that goes from negative infinity to negative 2, including 2. And we're joining that with a set that goes from negative 2 to positive 5, including 5. And joining that with the set that goes from 5 to positive infinity. But we don't want to express it this way because this is awfully complicated looking, right? In fact, if negative 2 is included and if positive 5 is included in this set, then our set is actually all real numbers from negative to positive infinity. In other words, the function is always defined for all real numbers of x that we can substitute into it. And so that would be it. All right, one more example in the next video.